हेलो स्टूडेंट्स, हाउ आर यू? कैसी तैयारी चल रही है? वेलकम टू माय यूट्यूब चैनल। स्वतंत्रता दिवस और आज़ादी के अमृत महोत्सव की ढेर सारी शुभकामनाएं। टुडे आई शैल डिस्कस अबाउट सॉलिड्स। मैटर एग्जिस्ट ऑन अर्थ इन थ्री फॉर्म्स: solid state, liquid state and gaseous state. One of the simplest state is gaseous state, and the solid state is one of the complex states. In our daily life, we come across solid state many times. So, solids can be classified into two types. Generally, solids are classified into two types. First one is amorphous solid and second one is crystalline solid. In case of amorphous solids, there is no ordered arrangement of constituent particles such as atoms, molecules, etc. For example, rubber is an example of amorphous solid, glass is an example of amorphous solid. There is no ordered arrangement of atoms. They do not have any sharp melting or boiling point. Now comes about crystalline solid. In case of crystalline solid, there is ordered arrangement of constituent particles. They have sharp melting and boiling points. The crystalline solids can be classified into four types. First one is molecular solid, second one is metallic solid, third one is ionic solid, and fourth one is covalent solids. Moleculars, in case of molecular solids, these classifications are based on the basis of binding forces. This classification is based on the basis of binding forces. In case of molecular solids, the constituent particles are molecules. Molecular solids can be further classified into three types. The first type is non-polar molecular solid. Non-polar molecular solid. For example, argon, helium are example of non-polar molecular solid in which atoms are constituent particles. Similarly, molecules such as nitrogen, iodine, chlorine are example of non-polar molecular solids. In these type of molecular solids, the binding forces are weak, dispersion forces are London forces. Due to the weak binding forces, they are soft, their melting and boiling points are very low. Due to the absence of free electron, they are non-conducting in nature. The second type of molecular solid is polar molecular solid. Polar molecular solid. In case of polar molecular solid, the binding forces are relatively strong dipole-dipole interaction. For example, in case of HCl, the binding forces are strong dipole-dipole interactions. Due to the relatively strong binding forces, the melting and boiling point of polar molecular solids are relatively larger than non-polar molecular solids. They are also soft, and at room temperature they generally exist in the form of gases or liquids. They are also non-conducting in nature. The third type of molecular solid is hydrogen bonded molecular solid. Hydrogen bonded molecular solid. In this type of molecular solid, the binding forces are relatively strong hydrogen bonds. For example, water. In case of water, the constituent particles are water molecules. There is strong hydrogen bonding between different water molecules. Let us consider one water molecule. Electronegativity of oxygen is more than hydrogen, therefore oxygen acquires partial negative charge. Another water molecule in which oxygen acquires partial negative and hydrogen acquires partial positive charge. Hydrogen atom of one water molecule binds to the oxygen atom of another water molecule through a weak force known as hydrogen bonds. Due to the presence of these hydrogen bonds, water exists in the form of ice. They also have low melting point and boiling point. They are also non-conducting in nature due to the absence of free electrons. They are hard, ice is hard in nature. After molecular solid, next is metallic solids. All the metals comes under metallic solids. Here the constituent particles are metals immersed in the sea of electrons. For example, copper, silver, gold, etc. These metals produce electrons. For example, silver produces electrons. These metal ions are bonded through the electrons through a strong electrostatic force of attraction. Due to this strong force of attraction, they have high melting and boiling point. Due to the presence of free electrons, these electrons can move when an electric potential is applied through the metal. They are conducting in nature. Metals are also thermal conductor due to the presence of electron. If we heat one end of a metal rod, then the heat flows from this end to the cold end. Metals have metallic luster. They have special type of luster. They are also malleable and ductile in nature. Third is ionic solid. In case of ionic solid, the constituent particles are ions. For example, sodium chloride, potassium chloride. These ions have three-dimensional structure. For example, in case of sodium chloride, each sodium ion is surrounded by 6 chloride ions in three-dimensional structure. Sodium chloride has cubic type structure, which will be discussed later. Similarly, each chloride ion is surrounded by 6 sodium ions. Due to the presence of strong Coulombic forces of attraction, they also have high melting and boiling point. Due to the absence of free ions or electrons, since sodium ion cannot move, they have fixed position. So in solid state, ionic solid are non-conducting in nature. But in molten state or in aqueous solution, they are conducting in nature. They can conduct electricity due to the flow of ions. Their melting point and boiling point are relatively high. They are brittle in nature. If we apply pressure, they cannot be shaped into thin sheets. Fourth one and last type of crystalline solid is covalent solid. In case of covalent solid, the constituent particles are atoms and the binding forces are strong covalent bonded. We know that covalent bonds are strong and directional in nature. Examples of covalent solids are silicon, carbide, diamond, graphite. Due to the presence of strong covalent bonds, their melting point and boiling points are very high. Due to the absence of free electron, they are generally non-conducting in nature. They do not show conduction in nature. Diamond is one of the hardest materials. Graphite is an exception of covalent solid which is conducting in nature and is also soft. Graphite have thin sheet like structure in which hexagonal sheets are arranged in thin sheets. These hexagonal sheets are arranged in layers. We can see that each carbon in graphite is bonded to three carbon atoms, three neighboring carbon atoms. So the fourth valency electron of carbon is free to move. If we apply electric potential, then it can flow across the layer. There is another layer of hexagonal sheets of carbon. These hexagonal sheets are held together by weak van der Waals forces. Due to the presence of weak van der Waals forces, these slits can slide over one another if we apply a pressure on these sheets. So graphite is soft in nature, soft and lubricating in nature, and is also used as solid lubricant. So in case of covalent solid, graphite is an exception which will have electrical conduction and soft in nature. Rest covalent solids are non-conducting and hard in nature. So crystalline solid on the basis of bending forces can be classified into four types: molecular solids, metallic solids, ionic solids, and covalent solids. Thank you for watching my lecture. You can suggest me any other topic you want to discuss later.